Alright, let's get started on section 7.6a, solve exponential and logarithmic equations. The first thing we're going to do is talk about exponential equations. Property of equality for exponential equations says, if b is a positive number other than 1, then b to the x equals b to the y if and only if x equals y, aka, or also known as, if the bases are the same, then the exponents are equal. So, for our first example, we have 9 to the 2x equals 27 to the x minus 1. Now, what we need to notice is that 9 and 27 are our bases, and they are not the same. So what I'm going to do is I'm going to do my factor tree to make them primes. So 9 goes to 3 and 3, 27 goes to 9 and 3, and then 9 goes to 3 and 3. So I'm going to replace 9 with 3 squared. So I have 3 squared to the 2x equals, now 27 is 3 cubed, so I have 3 cubed to the x minus 1. Now I have same bases. I have 3 and 3, so I can multiply my exponents. Now don't forget that I have to distribute there. So I have 3 to the 4x is equal to 3 to the 3x minus 3. Now, since I have the same bases, it says if the bases are the same, then the exponents are equal. So I can just set my exponents equal to each other, like saying 4x is equal to 3x minus 3. Now I just solve normal, so I minus 3x on both sides. So then I'm left with x is equal to negative 3. So I need to make sure that I have same bases, and then I can solve for my x. So for our next example, I'm going to break this down. So first I'm going to break down 81. 81 goes to 9 and 9. Then this goes to 3 and 3. And this goes to 3 and 3. So my base is going to be 3 for 81. So I'm going to have 3 to the 4th power to the 3 minus x equals. Now when I look at this one, I'm going, okay, how can I get my base to 3? And I notice that it's 1 over 3. Now to get my 3 back to the top, if I just make this to the negative 1 power, then I can have a base of 3. So I'm going to change this to 3 to the negative 1 power to the 5x minus 6. Now my negative 1 is going to flip it to where I have 3 instead of 1/3. Now I can do the same thing as I did before. I can distribute my 4, so I have 3 to the 12 minus 4x is equal to 3. Don't forget to distribute your 1. So I have negative 5x plus 6. Now, since I have same bases, I can set my exponents equal to each other. So I have 12 minus 4x equals negative 5x plus 6. So I can add 5x to both sides. So I get 12 plus x, because negative 4 plus 5 is positive 1, equals 6. And then I can subtract 12 on both sides with my equal sign. So I have x is equal to negative 6. Now for my last example, I have 100 to the 7x plus 1 equals 1000 to the 3x minus 2. So while I'm doing this, I can get my tens down, or my bases down. So 100 is the same as 10 times 10. So I have a pair here, so let's see if 1000 breaks down into tens. And I can do 10 times 100, and then 100 breaks down to tens as well. And I understand that these aren't primes, but they are the same. So I can make 100 10 squared to the 7x plus 1 equals 10 cubed to the 3x minus 2. And then as I do this problem, I can distribute this because these two multiply. So I have 10 to the 14x plus 2 is equal to 10 to the 9x minus 6. Now I have same basis, so I can set my exponents equal to each other. So I have 14x plus 2 is equal to 9x minus 6. So I subtract 9x from both sides. So then I get 5x is plus 2 is equal to negative 6. Then I subtract 2 from both sides. So I get 5x is equal to negative 8. Then I divide by 5. So I get x is equal to negative 8 over 5. And you can leave it like this instead of changing it to a decimal. Alright, so our next examples say, what if we can't get the same bases? First thing is we're going to switch to logarithmic form. Now we need to use the change of base formula. Now there's two different ways to do this. I'm going to do it one way with the first one and then the other way with the second one. The first thing I can do is I need to change it to logarithmic form. So I can do my little heart thing, and then I get log base 9 of 35 is equal to x. So I have this. And then I could do change of base formula. So then I do log of 35 divided by log of 9 is equal to x. And then when I punch this into my calculator, I get x is equal to 1.618. And this is an approximate, this is not the exact. So there's the first way to do it. The second way to do it is, let's look at number 2. We have 2 to the x equals 5. So if I take the log of both sides, I can take log of 2x equals log of 5. Now I can use the property where I pull my x out in front. So I have x log of 2 equals log of 5. And then I can divide by log of 2 on both sides. So I end up with x equals log of 5 over log of 2, and this is approximately 2.32. Now the last one, I'm going to do it the first way. So I have this here. I'm going to change this using my little heart thing. So I have log base 7 of 15 is equal to 9x. Now, what I need to do is I need to get x by itself. So I'm going to divide by 9 on both sides. So I have log base 7 of 15 over 9, or 1/9 times log base 7 of 15 is equal to x. And then I can just punch this into my calculator and get x is approximately 0.155. Okay, now to end this video, if you liked the other way better, I'm going to show you how to do the other way. So what I needed to do first, the other way, is take the log of both sides. So I have log of 7 to the 9x is equal to log of 15. Now I take my 9x to the front, so I have 9x of log to the 7th equals log of 15. Now I can divide both sides by log of 7. So then I'm left with 9x is equal to log of 15 over log of 7. Now I need to get rid of my 9, so one way I can get rid of my 9 is to multiply by 1/9 on both sides. So then I'm here, I have 1/9 of log to the 15 over 7. Oh shoot. Let's look back at this one. Where did I mess up? Hopefully you caught it before me. I have this. I need to do change of base. So I have 1/9 times log of 15 divided by log of 7 is equal to x, and then I can type this into my calculator. I cannot type this into my calculator. So this gives me x is approximately 0.155. And then if I look at this one, this is the exact same thing as this. So over here, x is equal to 0.155. And that is my answer. So you can either do it this way where you use the change of base formula, or you can just take the log of both sides and apply the power property. Okay, have a good night. Good night.